Okay, we're here at go-to-math.com. Click on the calculus and let's go down to the first derivative test. And I believe 10-2 is what we need to look at. And that looks like a good graph there. You can always change the problem by clicking right there, okay? Just click on the problem, change it. Find all relative minimum maximum points. So let's write this down and then head over to the whiteboard. Of course, we can see right here on the graph, right, where the minimum is actually occurring. But we want to prove that mathematically, and so that's what we're going to do. So we have f of x is equal to 0.65 absolute value times absolute value of x minus 4, and then we've got let's see, plus 10. Okay, so the first thing we want to do is take the derivative. F prime of x is equal to, so remember the derivative of the absolute value function, you just rewrite what's in the absolute value. Of course, don't forget we have to rewrite this coefficient here, so 0.65, rewrite what's in the absolute value, and of course, let's see, then we take the derivative of what's in the absolute value, put it out beside it, and that's just going to be 1, and then we're going to write all that over the absolute value of x minus 4, and of course the derivative of 10 is just 0. So then the next thing we do is set this thing equal to 0. I think I had, you might have seen this before, this exact problem. Maybe not with the exact numbers, but when we found increasing and decreasing and so forth. Okay, so now the question is, for example, let's look in the numerator. What could we plug in to get 0 up here in the numerator? And I'm going to write, now remember these are our critical numbers here. I'm going to write them down here, I suppose. So it looks like 4, right? And then what about the denominator? What could I plug in to get 0? Well, it's also 4. So 4 looks like that's going to be our only critical number. Alright, so we're going to do a number line. Attempt to draw one anyway. Okay, and then we're going to choose a test point. Now remember, this test point must be in the domain of the original function. I don't know if that's something I've said before or not. Put a circle around it, and then we'll choose 5 over here to the right of 4. Okay, so we want to find f prime of 0, and of course this must be also in the domain, obviously. Well, if you plug 0, let's look at this one. If you plug 0 in, you get what? Negative in the numerator, and of course the denominator is going to always be positive. Okay, so plug 0 in, we get negative. So this is going to end up being a negative number, so we'll put a little negative sign there. That means that the function is decreasing from negative infinity up to 4, and then we will do f prime of 5, right? So we plug 5 in, we get a positive number in the numerator, and the denominator will always be positive. So this looks like this would end up being a positive number, so we'll put a plus sign. Now, since we have decreasing up to 4 and then increasing after 4, this means that it's a minimum, right? It's going to be a minimum. And in order to find that minimum, okay, we know our x value is 4, and then we want to find f of 4. And of course, f of 4 is, if you plug 4 in right here, you see you get 0, and 0 times 0.65 is 0, so you end up with 10. And I guess I could have wrote that for 10, right? And remember, this is going to be a minimum. Okay, minimum. So it's pretty easy stuff. 1, 2, 3, 4, and what did we say? 10, something like that. All right. Of course, there it is. Okay, come on by, and I'll see you there maybe.